Today's episode is called The Judge Must Be Boring, the agent conformance pipeline end to end. So, when first building a governance layer for an AI agent, your first reflex would be to think, okay, I actually can use another LLM to be the judge of my first LLM, right? That's a terrible, terrible idea. For example, so what could happen is that you give it the same answers, but you show A and then B, and the other time you will show it B and then A, and it will pick quite often the first answer that you propose to it. So there is a paper that discusses precisely this. It says that a top judge here is an LLM, stays consistent only 65% of the time when you swap the order. It's really not reliable. This is something you really need to internalize. Having an LLM as a judge is a terrible, terrible idea. Just an LLM as a judge, of course. Also, it gets worse. Let's forget swapping. Even if you give it the same answers, like the same input, you might come out with different scores. So there is this Krippendorf alpha. I will let you search what is a Krippendorf alpha. It's an inter-rate reliability measure. And basically, the idea is that you need to understand is that over 3 runs, 3 scores, you have different 3 scores, self-agreement is falling to a very, very, very low figure. So we are here really barely above chance. This is from a paper from 2025. So the main idea here is that you can't build your governance on a coin flip. You need to have a reproducible outcome for your processes. I can hear people telling me, hey, there is an obvious fix for this. You can just set temperature for 0 and just use greedy decoding, no sampling. So these are all measures that you would take for if you want to stabilize the output of your LLM and make it deterministic, right? So you're solving your problem. No, it's actually a very bad idea. So if you run the same prompt 1,000 times at temperature 0, you can get 80 distinct completions. What I'm saying by that is that the same model, the same input, they first start diverging as early as token 103. So starting at 103, you start seeing your first divergences. This is measured from Thinking Machine Labs 2025 paper. So check it out. And the cause is not your random seed. It's not coming from what you inputted. The problem is that on shared server, the batch size changes with load, and the low-level kernels are not batch invariant. So the exact same input takes a slightly different arithmetic path depending on who else is on the box. The takeaway from the whole idea here is that you cannot make the judge boring. So do not put it in the load-bearing seed. So the downstream of all of this is the main idea that you have all of these tools that I'm explaining on my channel, between the inductive miner, the alignments, the process tree, the token replay, the declare over finite trace logic. So all of these are deterministic tools that if you give it a fixed block, you have plus a fixed model, plus a pinned library version, you will get the identical verdict every single run. Now, there is an honest caveat here, is that the alignment cost is deterministic, but which equally cheap alignment it returns depends on tie breaking. Meaning by this is that which specific one the tool hands back depends on its tie breaking rules, and those are implementation details. So know your library, know your version. It's part of being an engineer here. So a small tip I would give to you when you're building a system like this is that what you need to do is that you would need to use your normative model in the same way as talking about code. You need to version it, classify your logs compared to that normative model. So and that would create an evidence chain. So you have an immutable append-only trace store. You have an event log that is regenerable from those traces as long as we record the conversion choices, and a verdict recomputable from the log plus the norm version. So all of this is not really coming from literature. This is really recommendations I'm giving myself because this is something I believe myself. So that's the caveat that's the disclaimer I need to say here. So I wanted to say something. All of my argument is not actually a straw man. If you look at LangChain's agent eval's trajectory LLM as judge mode, they will actually say its own docs would call it less deterministic. Its own docs. So this is not something that I'm bringing myself. So you have the trajectory match for LangChain, which is more hard-coded and reference and such, and the trajectory LLM as judge. That's the other side. To be fair, that still has its own place. So trajectory LLM as a judge could be used for tone, for semantic quality, for helpfulness. Those are different metrics that are less objective, let's say. And my opinion is that from here it goes to deterministic conformance will be the load-bearing floor. Even when you're building your own system, you need to have a certain determinism in there. And it's a part that will deliver evidence for you. And the LLM judge sits on top of that for the fuzzy dimensions, that's for the tone. This is depending on the field where you are working. So this part is more like a complement. It cannot replace the deterministic floor. Now to recap this video, we have 3 things to carry. First, the judge is stochastic. LM verdicts flip on order and vary run-to-run. Having just an LLM as a judge is a bad idea. Don't do that, even at temperature 0. After that, we have how we can build the different tools we can build to build a deterministic pipeline. Please check my different videos that discuss these different terms. Also, determinism is evidence. This can be really interesting, for example, for auditing. Having evidence of why a certain agent took a certain decision can be very valuable for you. Now, if you keep one sentence from this whole video is that the agent is stochastic, but the pipeline after it must be boring. And boring is exactly what turns the verdict into evidence. So for next season, one gap is remaining, because this is the last episode of season 3 of our series, is the post hoc. It's how we catch the deviation days or weeks after the harm already happened. Now, doing it live as the agent runs will be the next video. If you like my content, please like and subscribe and follow me on LinkedIn. Thank you.